Let's look at another example of synthetic division and some of the changes we will have to make to either the dividend or divisor in order to ensure that synthetic division is going to work. Here we have 5x cubed plus 6x plus 8, all divided by the binomial x plus 2. Our rules for synthetic division are satisfied. We have a polynomial in the numerator written in standard form. We have a binomial in the denominator that has a coefficient of 1. Synthetic division's requirements are satisfied, so we can place the polynomial in and hopefully simplify it in a much more efficient fashion. The first thing to notice in comparison to our last example of synthetic division is that this divisor now has a plus sign in it. That does not change the work or the availability of synthetic division, but remember from the previous example that we want that to be a minus sign. So in order to think of this binomial as having a minus sign in it, we need to reconsider it as x minus negative 2. So when we set up our synthetic division, negative 2 is the number that's going to be on the outside doing the dividing in the synthetic division. Next, we place the coefficients of the divisors from left to right in decreasing order. One thing you'll notice about this polynomial dividend is that the x squared term is missing. So we're going to need to add in, similar to what we did with polynomial long division, that spacer term of 0x squared. So we'll say 5 is our first coefficient, then the 0 for the x squared, then a 6, and then an 8. Once that is set up, polynomial long division can be shortened with synthetic division. We're going to bring the 5 down. That's just, remember, that first division that we would normally do. We create this number going diagonally by multiplying negative 2 by 5, very similar to what we did in long division, just writing it a different way. So here we're going to have negative 10. We're going to then add down and get negative 10 as part of our result. We'll multiply again, the negative 2 times the negative 10, and we get 20. 6 and 20 makes 26. Multiply to go diagonally, one more time, and that's going to be negative 52. Add down, and we get negative 44. Our original dividend went x cubed, x squared, x, and then a constant. So our resulting polynomial is going to go x squared, x, the constant, and then our remainder. So writing it out as a polynomial, will be 5x squared negative 10x plus 26 and then minus 44 over x plus 2. Using each of these powers of x and the constant and the remainder to become the coefficients in our resulting quotient polynomial.